With question 19, we're interested in how much AH is left after we've added that sodium hydroxide. So what I'm going to do is I'm going to find the initial moles, and I'm going to do everything here. We're really only interested in the AH though, so if you didn't want to do the A minus, that'd be fine. But I'm going to go ahead and do the A minus anyway. So the moles of AH is going to be 0.716 mole per litre multiplied by 0.2419 litres, which is the milliliter value in litres, and that gives us 0.173 moles. The moles of A minus, 0.797 mole per litre times 0.2419 litres, and that comes out to be 0.193 moles. Now we do definitely need the moles of OH minus. We'll go ahead and do that. And that's going to be 0.493 moles per litre times 0.02837 litres, which comes out to be 0.0140 moles. Now the moles of AH here that are left after we add the OH minus will be the initial moles of AH minus the initial moles of OH minus, which is going to be 0.173 moles minus 0.0140 moles, which comes out to be 0.159 moles. Now, the justification for this is that let's say we've got a picture here and we've got pretty much equal amounts of A minus and AH in our solution. When we add in OH minus, it's not going to react with the A minus, it'll react with the AH. And the reaction looks like this. So what we find is that for every mole of AH we have, for every mole of OH minus that we add, it will use that many moles of AH as well. So that's how we're going to justify the loss of AH. It actually turns into A minus, that ends up going up, but the AH, that ends up going down, and that's why it's initial moles of AH minus initial moles of OH minus.